the denominator stuff. Do I have any x's in the denominator I got to worry about? All my denominators are numbers, just plain old numbers, right?
Yes.
Okay, so we don't have to worry about any denominators being 0 because my denominators, no matter what x's, are going to be 5, 2, 3, and 10. Okay? So the related equation, this is fun just recopying the whole problem.
So you don't distribute?
Oh, I will.
Oh,
But the very first thing I do before I do anything else is make that an equal sign before I forget.
okay.
Okay? What I said last time is when I see students not change it to an equal sign, they confuse themselves into thinking some things are true that aren't really true. Okay? So make it equal so you're not tempted to be confused. No more than what's necessary. Alright? So this is an equation. We've got lots of fractions. And fractions are problematic, so let's clear fractions, right? So what's my lowest common denominator? I need something that 5, 2, 3, and 10 I'll go into. 30. Everything's going to, everything's going to go into 30, right? So I'm going to go through, multiply by 30, multiply by 30, multiply by 30, and multiply by 30. I got to multiply 4 things by 30. And the multiplying by 30 is designed to cancel everything from a denominator, right? So right here, when I do 1/5 x times 30, what I'm really thinking is how many times does 5 go into 30? 6. So yeah, that's 6 times x, 6x. And then what's half of 30?
15.
So plus 15x minus 1/3 of 30 is 10 times that x plus 5 equals 3. And all of a sudden it's a much easier problem, right? In fact, it's just a linear equation, I think. At this point, yeah, we're not going to have like any x squared or anything like that. So that's 21x minus 10x minus 50 equals 3. So 11x minus 50 equals 3. And I'm getting x equals 53 over 11. Are y'all getting that? Should have brought 2 of these guys. So good. Okay, so that's my critical number. It's my one and only critical number. Okay, before we go on, I want to make a concession. There's a very good chance that some of you guys were taught some other things about inequalities in the past, and they sometimes still hold up. So I'm talking about things like, do you ever remember math teacher telling you about something like dividing by a negative and you flip? Does that ring any bells? Okay, some of those guys are still kind of sort of in play. I don't really want to go into them just because that would take an extra 20, 30 minutes. If you know with crystal clear certainty how those rules work and you want to use those rules, that's okay. I'm not going to discourage you from using them. All I'm going to say is that if you think you know them but you're using them wrong, then you're wrong.